This is the brief on the medical science behind In Darkness We Sleep. Welcome to a quick sidetrack we call Read and Learn, where we focus on the facts behind the fiction.
The medical information covered in this podcast is for information only and not a medical diagnosis or explanation of any specific real-world case.
Right. Always important to get that out of the way first.
Exactly. So if I told you right now that a generic, everyday blood pressure pill-like, something you'd just pick up at the local pharmacy for your heart, could actually stop a psychiatric nightmare in its tracks, you'd probably think I had my medical charts completely crossed.
I mean, it sounds totally impossible on the surface. We're so conditioned to think of mental health and physical health as these two completely separate universes, you know? You treat the body with one set of tools, and then you treat the mind with another.
Right. But what we're learning in this deep dive is that, well, that division is kind of a total illusion, especially when you start looking at trauma. And if you're listening to this, you've almost certainly heard the term PTSD thrown around.
Oh, constantly. People use it as a punchline now.
Yeah, like for a bad day at work or, a stressful commute. But if you want a real shortcut to being genuinely well-informed about human resilience, you really have to look past the casual slang and understand the physical mechanics of what's happening inside the body.
And, the medical consensus on those mechanics has shifted so dramatically over the last few years. The sources we're digging into today, we've got peer-reviewed literature from PubMed, clinical insights from the UCLA Medical School, and some pretty paradigm-shifting research out of Yale.
It's a heavy stack.
It is, yeah. But they all paint this picture of a condition that is just profoundly physical.
So our mission today is to totally strip away the stigma and the misconceptions around PTSD. We're going to open up the hood and look at the physical, neurobiological reality of how trauma rewires the brain circuitry.
And how science is figuring out ways to rewire it back.
Yeah, exactly. And to kind of ground this in a human story, because the medical jargon can get pretty dense, we're actually going to weave in a really fascinating fictional parallel today. We're looking at the character Jason Matherson from the book In Darkness We Sleep.
Oh, right. That's such a perfect example for this because, it highlights the absolute tragedy of misdiagnosis.
Yeah, I mean, in those early chapters, Jason's situation is just heartbreaking. But before we get into Jason's story and brain structures and all that, we really need to redefine our terms, like what PTSD actually is.
And what it isn't, because the medical definition itself has completely evolved.
Right, so let's start with the most basic confusion. A lot of people, use the words trauma and PTSD like they mean the exact same thing, like, I went through trauma, therefore I have PTSD.
And clinical experts like Dr. Orellana from UCLA, they are very quick to point out that this is a fundamental misconception. Trauma, strictly speaking, is just a negative emotional response to a highly stressful or dangerous experience.
It's a normal response.
Exactly. It's a completely normal response to a completely abnormal situation.
I really want to highlight that for you listening. A normal response to an abnormal situation. Like, if you're in a horrific car crash, your brain and body are supposed to react intensely. That's just your survival mechanism kicking in.
Yeah, the DSM-5 doesn't even list trauma itself as a disorder. The trauma is just the event and the immediate aftermath. PTSD is a very specific diagnosed condition that can develop long after that event is over.
So the symptoms have to persist for, what, over a month?
Right, more than a month, and they have to meet very strict criteria. If it's under a month, it's usually just looked at as an acute stress disorder.
Okay, so if I'm thinking about this visually, experiencing trauma is kind of like getting a deep physical cut on your arm. It hurts, you bleed, your body floods the area with white blood cells. That inflammation is a totally healthy biological reaction to an injury.
It's what's supposed to happen.
Right. But PTSD is what happens when that cut gets severely infected and just fails to heal. The trauma is the original wound, but PTSD is the chronic infection.
And our understanding of that infection has totally changed. Like, for decades, psychiatry categorized PTSD strictly as an anxiety disorder. But with the DSM-5, they actually pulled it out of that category entirely.
Really? Into its own thing?
Yeah, it was moved into a distinct group called trauma and stress-related disorders.
That seems like a massive bureaucratic shift, though. I mean, why take it out of the anxiety bucket if anxiety is such a huge part of it?
Because categorizing it just as anxiety reduced the entire condition down to a single emotion, fear. And the actual lived experiences of patients were telling a way more complicated story. It affects how you think, your mood, your physical bodily sensations, your behavior.
Which connects perfectly to that Yale School of Medicine study in our stack today. When I was going through the notes on that, the data genuinely stopped me in my tracks.
The symptom profile study, it's a landmark piece of research.
Right, so they asked individuals diagnosed with PTSD to rate which symptoms actually impair their daily lives the most. And they found that almost 70% of the participants rated emotional pain as significantly more debilitating than fear.
70%. It's staggering.
Well, wait, really think about that. Emotional pain over fear. Because the entire cultural stereotype of a PTSD patient is someone who is, jumping at loud noises, constantly looking over their shoulder.
Yeah, hyper fearful.
Exactly.
Yeah.
But you're saying the primary issue destroying their quality of life is internal pain.
Yes. And Dr. Elin Harpaz-Rotem from Yale made this crucial point. If you want to develop an effective treatment, you have to target what's actually driving the suffering. If a patient is primarily paralyzed by a profound sense of grief and emotional agony, but you only give them treatments for panic,
The treatment is going to fail.
it's going to fail completely.
It's like putting a cast on a broken arm but completely ignoring internal bleeding. And this is where I want to bring in Jason Matherson from In Darkness We Sleep, because Jason is dealing with this intense, explosive anger and profound emotional pain.
Which everyone around him just chalks up to wartime PTSD.
Right. Everyone assumes it's trauma from his deployment. But if trauma is a normal response, why do only some people get the PTSD infection? Like, what tips the scale for Jason or for anyone?
Well, to answer that, we have to stop talking about psychology and look at the hardware. The neurobiology of how this condition physically alters the brain, starting with the amygdala.
Okay, the amygdala, that's
Yeah.
deep in the brain, right?
Yeah, evolutionarily, it's very ancient hardware. Its primary job is threat detection. You can kind of think of it as your body's built-in alarm system.
Like a smoke detector.
A smoke detector, exactly. And when researchers do MRI scans of people with PTSD, they consistently see that the amygdala is hyperactive. The sensitivity dial is cranked all the way up, blaring 24/7.
It's triggering a massive response to any threat, even if the person is just sitting safely on their couch.
Right.
But in a healthy brain, doesn't something step in to turn it off? Like if I burn toast and my smoke detector goes off, I wave a towel at it until it stops? What's the brain's towel?
That would be the prefrontal cortex. That's the front part of your brain, responsible for complex decision-making and logic. It evaluates the situation, realizes there's no danger, and tells the amygdala to tone it down.
But in PTSD.
In PTSD, the regulatory capacity of the prefrontal cortex is fundamentally dysregulated. It's weakened.
So the amygdala is this malfunctioning smoke detector just screaming. And the prefrontal cortex is the exhausted homeowner, desperately flapping a towel but completely failing to turn the alarm off.
And the longer that homeowner flaps the towel, the more exhausted the whole nervous system becomes. The body is forced into a state of acute sympathetic nervous system arousal.
Hypervigilance. And this isn't just a subjective feeling, right? The body is literally flooding with chemicals.
Totally physiological. The brain dumps catecholamines, heavy-duty stress chemicals like adrenaline and cortisol into your bloodstream. Your heart rate skyrockets, your blood pressure elevates. The body is locked in a combat-ready state.
Which is why you see that fear-potentiated startle response. The baseline arousal is so high that a sudden noise causes a massive involuntary whole-body reaction.
Exactly. But there's a third major player here that the sources highlight, which makes Jason Matherson's fictional case so tragically relevant: the hippocampus.
Right. The hippocampus, that's the memory center.
It is. It's the brain's filing cabinet. It takes events and files them into long-term memory. And multiple large-scale studies in PubMed show that people with PTSD often have a significantly reduced total hippocampal volume. Their hippocampus is physically smaller.
Okay, hold on. I got to push back on this.
Okay.
Because that feels like a chicken and egg situation. Did the terror of the trauma, and all that toxic cortisol batter the hippocampus until it shrank? Or were they just born with a smaller one, making them vulnerable?
It's an excellent question, and it drove a massive debate in psychiatry. So researchers at the VA turned to twin studies. They found identical twins where one deployed to a combat zone and got PTSD, and the other stayed home with no severe trauma.
Oh, that's brilliant. Same genetics.
Right, and they found that both twins had a smaller than average hippocampus.
Wait, even the twin who never went to war?
Even the civilian twin, which proved that a smaller hippocampal volume is actually a pre-existing structural risk factor.
That is mind-blowing. So what tips the scale is literally the structural baseline of your brain before the bad thing even happens. One person has a robust filing cabinet, the other have a tiny one that gets overwhelmed.
Precisely. And this is where Jason's story is such a brilliant cautionary tale about physical hardware. Everyone in the book assumes his anger, his emotional pain, his inability to recall events are all just wartime PTSD.
But it's a misdiagnosis.
Exactly. His issues are actually stemming from physical brain damage, a traumatic brain injury, a TBI from a car accident.
Right. And the PubMed literature notes that TBI massively complicates things. If you have actual physical bruising and inflammation of the brain tissue, it drastically exacerbates the molecular adaptations caused by stress. It's a double hit.
It's a massive hardware failure that mimics PTSD, but requires a totally different understanding.
Which brings up the memory aspect. Because whether it's PTSD or a TBI like Jason has, what happens when these people go to sleep? Does the system finally shut down?
No, sleep is actually where the battle is most fiercely fought. The literature shows that sleep disturbances, severe insomnia, fragmented sleep, they're core drivers of the condition.
Is it just the adrenaline keeping them awake?
It's specifically a disruption of REM sleep, rapid eye movement sleep. Normally, REM is when the magic of memory consolidation happens. The brain suppresses stress chemicals, pulls up a scary memory, strips away the emotional charge, and safely files it in the hippocampus as a past event.
Like unplugging a live wire and putting it in a safe box.
Exactly. But in PTSD, we see severe REM sleep fragmentation. The REM cycle constantly breaks down.
So the filing cabinet gets jammed right when it's trying to store the trauma.
The brain actively tries to process the horrific memory, but because REM shatters, the memory never gets filed under the past, so it just loops it. It boots up the horrific event over and over, manifesting as violently vivid nightmares.
It's like a computer crashing every time you try to save a corrupted file. It just keeps rebooting.
And this failure to consolidate memory leads to declarative memory deficits.
Meaning the person literally cannot remember important details of the event itself.
Right. The DSM-5 lists this inability to recall aspects of the trauma as a diagnostic criterion. Historically, police or family members would view this as suspicious, like the person is lying or in denial.
Which is exactly what happens with Jason. He struggles to recall events, and people judge him for it. But the neuroscience proves it's a genuine hardware failure. The hippocampus was compromised, the REM sleep shattered, the memory just didn't encode.
It's physiologic.
So if the brain is physically stuck in this loop, how do we fix the hardware? Because my instinct is you just prescribe a heavy-duty pill, drug the amygdala into submission.
That's the assumption. But recent VA and DoD guidelines prioritize trauma-focused psychotherapy over long-term medication.
I really have to challenge that, though. We just spent all this time establishing that PTSD is a physical hardware failure. Shrunk hippocampi, hyperactive amygdalas. How does talking on a couch fix a hardware problem?
Because these therapies, like cognitive processing therapy or EMDR, they aren't just talking about feelings. They are rigorous interventions designed to force neuroplasticity.
The brain's ability to physically rewire itself.
Right. They safely expose the patient to the memory, forcing the prefrontal cortex to engage. It's essentially neurological reps. It strengthens the physical connection between the prefrontal cortex and the amygdala to extinguish the fear response.
So it's physical therapy for the brain, putting the exhausted homeowner in the gym until they can finally turn off the smoke detector?
Exactly. Now, medications are still part of the toolkit. The FDA has approved certain SSRIs, antidepressants, like sertraline for PTSD.
How do those fit in?
They increase serotonin, which helps elevate mood and tone down daytime anxiety. But the literature points out a major blind spot: SSRIs often fail completely at addressing the nightmares and the fragmented REM sleep.
Which brings us back to the hook of this entire deep dive. What do you do when the conscious brain is off and the nightmares take over? Enter the blood pressure pill.
Persist.
Yes. Persist is an alpha-adrenergic antagonist. It was developed for high blood pressure, but VA doctors noticed a miraculous side effect. Veterans taking it for their heart were reporting their combat nightmares had stopped.
How does that even work mechanically?
It competitively inhibits the alpha-adrenergic receptors. Basically, it blocks the specific neuroreceptors that respond to adrenaline.
It's like putting a dummy key into a lock. Prazosin fills the keyhole, so when adrenaline tries to start the panic engine during sleep, the lock is already blocked. The sympathetic nervous system can't trigger that massive spike in heart rate. By putting a ceiling on the physical panic, the brain finally stays asleep. The nightmare loop is broken.
I just want you listening to pause and appreciate that. A blood pressure pill, stopping a psychiatric night terror. It is undeniable proof that PTSD is a whole-body condition happening in your physical neurochemistry.
It completely dismantles the artificial wall between mental and physical health.
And contrast this real, empowering medical science with the tragedy of Jason's story in Darkest We Sleep. Instead of getting Prazosin or EMDR or a proper TBI diagnosis, he gets exploited.
Oh, Willie and Gloria, it's horrifying what they do to him.
They literally use fictional hallucinogens to keep him trapped in this liminal space, this weird dreamscape, just to keep him compliant and confused. They exploit his memory gaps instead of giving him genuine medical help.
It's the ultimate betrayal of a vulnerable patient. They use his hardware failure against him.
Exactly. But understanding these mechanics in the real world, the jammed filing cabinet, the sleep fragmentation, it's a tool for empathy. When you realize someone's brain is physically looping a memory because it lacks the biological capacity to save the file, it changes how you support them.
Knowledge has to be applied to be valuable. By recognizing PTSD as a physiological rewiring, we can strip away the stigma of illness and treat people with the medical precision they deserve. And that precision is moving into some wild frontier science.
Oh, lay it on us. Where is the research heading next?
Researchers are now discovering that severe PTSD is associated with advanced epigenetic aging in the brain. Using PET imaging, they're finding widespread accumulations of tau proteins in the cortexes of PTSD patients.
Tau proteins. Wait, aren't those the sticky clumps we associate with Alzheimer's?
Exactly the same proteins. Chronic, untreated trauma isn't just rewiring circuits. It appears to be accelerating the physical aging process of the brain cells. It alters DNA methylation.
And just to clarify, DNA methylation, that's epigenetics. It's not mutating your DNA letters, it's just flipping physical on and off switches that sit on top of your genes. The trauma leaves a molecular scar that changes gene expression. The biological clock of the brain ticks faster. That is heavy. But it raises a massive question. If severe stress is flipping epigenetic switches on our DNA, what does that mean for generational trauma? Are survivors passing these hyperactive smoke detectors down to their kids?
That is exactly the question science is racing to answer. It suggests the next frontier of precision medicine might not just be therapy, but finding ways to reverse that molecular scarring and slow down the genetic clock itself.
We started this deep dive talking about how much we prefer the clean precision of an X-ray showing a broken arm. But maybe the muddy waters of PTSD aren't so muddy once you look at the hardware. We might not have a simple X-ray for a fractured sense of safety yet, but the science is getting closer every single day.
The invisible wound is finally becoming visible.
And that is something for all of us to mull over today. Until next time.